This will be a video explaining how to use an indirect truth table for an invalid argument and what that looks like. So what I do for these indirect truth tables, just to recap, is I'm going to go and work my way from the really simple stuff first, where it's just one claim, really, and then work my way to the complicated one to see if that's possible, given these values that I'll discover over here. So this is the conclusion that I want to be false. For this conclusion to be false, well, I need D to be true. Once it's true, the negation will flip it to false, which is what I want it to be, so D is true. I'll next go here. I want this one to be true because it's a premise. For this to be true, I need F to be false. Same thing here. I want this to be true because it's a premise. For G to be true, not G to be true, this G needs to be false. So just recap here. I want not D to be false, which means I need D to be true. I want not F to be true, which means I need F to be false. And I want not G to be true, which means I need G to be false. Okay. I now have the values for each of these parts of this more complicated claim here. And I'm just going to work it now to see if it's possible for this premise to be true. Because if it is, well then I've got true premise, true premise, true premise, false conclusion. That would show the argument is invalid. If this isn't possible to be true, well then that would show that the argument cannot be one in which all the premises are true and the conclusion is false. So that would show that it's valid. But this should be an argument where it's going to be invalid, because I could get this to be true. So here's how I'll do it. I know that if a conditional claim has a true second part, a true consequence, then automatically it's true. And because G is false here, well, not G would be true. So I would know at this point that this was valid. I think that this will probably make me fill out some other stuff, and I'll go ahead and do it for you. But true consequent would automatically make this true. But just to show you, what I would do here is work this piecemeal, flip these signs, so this becomes false. This one becomes true. And then I'm going to look at these two things to determine whether the OR claim is true or false. In this case, it would be true. And so what I'd be left with, gotta keep track of all this stuff, is a case where I'm now looking at true antecedent, true consequent. Therefore, the whole thing would be true. And so this would actually be an invalid argument because I'd have true premise, true premise, true premise, false conclusion. So that's an example of what an invalid argument would look like and how you show that using an indirect truth table.